This is Algebra II, 8.3a, and this is equations and quadratic formulas, and I have a theorem for you. So we're piling up our previous videos for Chapter 8. If you've become lost or confused during this video, you can click on the description and watch the ones you've missed, and you should be okay then. And some quadratic equations can be solved by factoring, and some by finding the square roots, but all quadratic equations can be solved by completing the square. A formula was obtained from the concept of completing the square. We call it the quadratic formula. And we talked about this last year in Algebra I, since it helps us and computers to solve all quadratic equations. They call it the quadratic formula. And this is it right here. And we read this formula as x equals inverse of b plus or minus the square root of b squared minus 4ac, and it's all divided by 2a. So all we have to do is take our quadratic equation with our a, b, and c constants and substitute it into this formula. All right? So here's our theorem. It's for the quadratic formula. The solutions of any quadratic equation with complex coefficients, ax squared plus bx plus c equals 0, that's in its standard form, right, are given by the quadratic formula x equals the inverse of b plus or minus the square root of b squared minus 4ac, and it's divided by 2a. So here's the standard form of a quadratic equation, this ax squared plus bx plus c equals 0. So we can solve this equation right here, this quadratic equation. First, we're going to rewrite it into standard form so it's like this. So we need to set it so it equals 0. So we're going to add a 1 to each side of the equation. So this is an additive inverse, and the 0 pair becomes a 0, and now we have a plus 1 over here. Now it matches that form, doesn't it? Now, what we're going to do is we're going to use 3 as our A, 5 as our B, and 1 as our C. I'm going to substitute everything into the formula. So now we've got x equals the inverse of 5 plus or minus 5 squared, the square root of 5 squared, minus 4 times 3 times 1, and it's divided by 2 times 3. See, we substituted our values in. Now all we have to do is simplify it. There's a little negative 1 in front of this parentheses, isn't there? So we can distribute that negative to the 5, so we have negative 5 plus or minus, and 5 squared is 25, so we have the square root of 25 minus 4 times 3 is 12 times 1 is still 12, and it's a negative, isn't it? Now we can do the 25 minus the 12, can't we? And we get a square root of 13. So now we have negative 5 plus or minus the square root of 13 divided by 6. And because of this plus or minus here, that means x is equal to the inverse of 5 plus the square root of 13 divided by 6, and x is equal to the inverse of 5 minus the square root of 13 divided by 6. See? When we use the quadratic formula, the solutions we get are always solutions of the original equation, unless we made a math mistake, a math error, okay? Now, let's see what happens now. When an expression under the radical sign is a negative, we get a complex solution. We get complex solutions. So we're going to use I. We learned about that in Chapter 7, didn't we? So we can solve x squared plus x plus 1 equals 0. That's in the standard form of a quadratic equation. A is going to be a 1, because there's an invisible 1 there, isn't there? B is going to be a 1, because he has an invisible 1, and we can see that C is 1. And we substitute these values, these 1s, into the quadratic formula, and we simplify it, okay? So 1 squared is 1, isn't it? And negative 4, the inverse of 4 times 1 is still a negative 4, isn't it? So we have 1 minus 4. So remember what we have to do when we have a negative 3 here, right? We factor it as a negative 1 times 3. We can pull this out as the letter I, can't we? We did that in video 7.7a. There's going to be a link in this description for it. So now we've got x equals the inverse of 1, negative 1, plus or minus I times the square root of 3. See? Divided by 2. And we can open this plus or minus up, can't we? We can say it's plus I square root of 3 or minus I square root of 3, can't we? All right? So if you're lost or confused, please look in this description for the links to help you, okay? It's easier to climb a ladder if steps aren't missing, right? I keep saying that. Our next video is going to be 8.3b. We're going to talk about how to approximate to get solutions for quadratic equations. I'm going to add this video to the Algebra II playlist. And back in Algebra I, we talked about this in 13.4a and b. In 13.4b, we talked about discriminants. And we're going to be talking about that coming up in a couple videos. And all the previous videos for Chapter 8 are all going to be linked in this description, so you can just click on them, all right? Make your life easy. Try not to miss any steps, and everything will be fine. Oh, and before I forget, I wanted to show you if a is equal to 0, it's not a quadratic equation, okay? So just remember, if a is a 0, then that means that we're going to have a denominator that's a 0. And we can't have that, right? It's undefined. So, all right, I'll see you next video, and I hope you're doing well. Keep trying. I'm proud of you. Bye.